Download this code from codegive.com, link in the description below. 10 bad crankshaft position sensor symptoms, diagnose, fix, and code examples. The crankshaft position, CKP, sensor is a critical component in your engine management system. It tells the engine control unit, ECU, the exact position and speed of the crankshaft. This information is essential for accurate fuel injection, ignition timing, and overall engine operation. A faulty CKP sensor can lead to a host of problems, from poor performance to a no-start condition. This guide will cover 10 common symptoms of a bad CKP sensor, how to diagnose the issue, potential fixes, and provide some code examples to illustrate how the sensor works and what to look for in diagnostic trouble codes. Understanding the crankshaft position sensor. Before diving into the symptoms, let's briefly understand how the CKP sensor works. Types. CKP sensors primarily come in two types. Magnetic inductive sensor, variable reluctance sensor. This type contains a coil of wire and a magnet. As the crankshaft's teeth, or a reluctor will attach to the crankshaft, pass by the sensor, they change the magnetic field, inducing a voltage in the coil. The frequency and amplitude of this voltage signal change with engine speed. Hall effect sensor. This type uses a semiconductor crystal that generates a voltage when exposed to a magnetic field. A reluctor will interrupt the magnetic field as it passes the sensor, creating a digital signal, on/off, that the ECU interprets. These sensors typically require a 5V power supply. Location. The CKP sensor is usually located near the crankshaft pulley, at the front of the engine, or the flywheel/flex plate, at the rear of the engine. Its positioning allows it to read the position of the crankshaft as it rotates. Function. The sensor generates a signal that the ECU uses to determine engine speed, RPM. Determine the precise position of the crankshaft. Synchronize fuel injection and ignition timing. Detect misfires. 2. 10 common symptoms of a bad crankshaft position sensor. 1. Engine stalling or hesitation. Description. This is one of the most common symptoms. The engine may stall randomly while driving, especially when decelerating or idling. It might also hesitate, a momentary loss of power, during acceleration. The stalling may be intermittent, making diagnosis more challenging. Cause. The faulty sensor is sending an inaccurate or intermittent signal to the ECU, causing the fuel and ignition timing to be off. Severity. Moderate to severe, stalling can be dangerous. Too hard starting or no start condition. Description. The engine may crank but fail to start. This is because the ECU needs the CKP sensor signal to initiate fuel injection and spark. If the sensor isn't providing a signal, the ECU might not activate these systems. Cause. The sensor is completely failing or providing a severely distorted signal. Severity. Severe, renders the vehicle unusable. 3. Check engine light, cell, illumination. Description. The cell will often illuminate, indicating a problem with the engine management system. This is often your first clue that something is amiss. Cause. The ECU detects a discrepancy in the CKP sensor signal, out of range, intermittent signal, missing signal, etc. Severity. Varies, but should always be investigated. Ignoring the cell can lead to further damage. 4. Rough idling. Description. The engine idles roughly, exhibiting vibrations or erratic RPM fluctuations. Cause incorrect fuel and ignition timing due to faulty CKP sensor data leads to uneven combustion. Severity mild to moderate, can be annoying and affect drivability. 5. Poor acceleration description the vehicle accelerates slowly or feels sluggish, even when pressing the accelerator pedal fully. Cause the ECU relies on the CKP sensor for optimal power delivery. A faulty signal will limit the engine's ability to produce power. Severity moderate, affects performance and can be dangerous in certain situations, example merging onto a highway. 6. Misfires description the engine may experience misfires, which you might feel as a sudden jerk or shudder. You might also hear a popping sound from the exhaust. Cause the CKP sensor provides the ECU with the crankshaft position, which is essential for correct spark timing. A faulty sensor can result in incorrect ignition timing, leading to misfires. Severity moderate, can damage catalytic converters and other engine components. 7. Reduced fuel economy description you may notice a decrease in your vehicle's fuel efficiency. Cause the ECU adjusts fuel delivery based on information from various sensors, including the CKP sensor. A faulty sensor may cause the ECU to inject more fuel than necessary, leading to reduced fuel economy. Severity mild to moderate, increases operating costs. 8. Backfiring description loud popping or banging sounds coming from the exhaust system, often occurring during deceleration. Cause incorrect ignition timing can cause unburned fuel to ignite in the exhaust system. Severity moderate, can damage the exhaust system. 9. Inability to shift gears, automatic transmissions. Description some automatic transmissions rely on engine speed information from the CKP sensor for proper shifting. A faulty sensor can cause erratic or delayed shifting. Cause the transmission control module, TCM, needs accurate engine speed information for smooth gear changes. Severity moderate to severe, affects drivability and potentially damages the transmission. 10. RPM gauge inconsistencies description the RPM gauge on the dashboard may fluctuate erratically or show inaccurate readings. Cause the CKP sensor signal is directly related to the engine's RPM. A faulty sensor can send incorrect data to the instrument cluster. Severity mild to moderate, indicates a problem with the engine management system. 3. Diagnosing a bad crankshaft position sensor Diagnosing a faulty CKP sensor requires a systematic approach. 1. Check the check engine light, cell. Use an OBD2 scanner to retrieve diagnostic trouble codes, DTCs. Common codes associated with CKP sensors include P0335, crankshaft position sensor A circuit malfunction. P0336, crankshaft position sensor A circuit range/performance. P0337, crankshaft position sensor A circuit low input. P0338, crankshaft position sensor A circuit high input. P0339, crankshaft position sensor A circuit intermittent. P0340, crankshaft position sensor B circuit malfunction. If applicable, some engines have two CKP sensors. P0341, crankshaft position sensor B circuit range/performance, if applicable. P0342, Crankshaft position sensor B circuit low input, if applicable. *P0343, crankshaft position sensor B circuit high input, if applicable. *P0344, crankshaft position sensor B circuit intermittent, if applicable. Write down all the codes and research them. Sometimes, multiple codes appear, indicating other related issues, example Crankshaft position sensor problems. 2. Visual inspection ***. Locate the CKP sensor. Refer to your vehicle's repair manual for its exact location. Inspect the sensor for any visible damage, such as cracks, breaks, or corrosion. Check the wiring harness and connector for loose connections, frayed wires, or damage. 3. Wiring and connector check Continuity test Use a multimeter to check the continuity of the wires between the CKP sensor connector and the ECU connector. Disconnect the battery before doing this. Voltage check with the ignition on, but engine off, check for the presence of voltage at the CKP sensor connector. Hall effect sensors typically require a 5V reference voltage. Use your vehicle's wiring diagram to identify the correct pins. Ground check ensure the ground wire, if present, has a good connection to the chassis ground. 4. Sensor resistance test Disconnect the CKP sensor. Use a multimeter to measure the resistance across the sensor terminals. Compare the measured resistance value to the specifications in your vehicle's repair manual. An out-of-range resistance value indicates a faulty sensor. 5. Oscilloscope test, advanced. Connect an oscilloscope to the CKP sensor signal wire. Start the engine and observe the waveform produced by the sensor. A healthy sensor will produce a consistent and regular waveform. A faulty sensor might produce a weak, distorted, or intermittent signal. This is the most reliable method of diagnosis. 6. Scan tool data monitoring Connect a scan tool that can display live data. Monitor the CKP sensor signal while cranking the engine. The scan tool should show an RPM reading. If the scan tool doesn't register any RPM while cranking, the CKP sensor is likely not functioning correctly. 4. Fixing a bad crankshaft position sensor ***. 1. Replacing the CKP sensor ***. Disconnect the negative battery cable. Locate the CKP sensor. Disconnect the electrical connector. Remove the retaining bolt, S, that secure the sensor. Remove the old sensor. Install the new sensor, ensuring it is properly aligned. Tighten the retaining bolt, S, to the specified torque. Reconnect the electrical connector. Reconnect the negative battery cable. Start the engine and check for proper operation. Clear any DTCs stored in the ECU using an OBD2 scanner. Important some vehicles may require relearning the CKP sensor position after replacement. Refer to your vehicle's repair manual for specific instructions. 2. Repairing wiring or connectors If the problem is with the wiring or connectors, repair or replace them as needed. Use proper splicing techniques and ensure a secure connection. Protect the repaired wires with heat shrink tubing or electrical tape. 3. Addressing related issues If other DTCs are present, address them as well. A faulty Crankshaft position sensor can sometimes mimic CKP sensor symptoms. Check for other potential causes of the symptoms, such as a faulty ignition system or fuel system problem. V code examples, illustrative. These code examples are simplified and for illustrative purposes only. Actual ECU code is much more complex. They demonstrate how the ECU might use the CKP sensor signal. Example 1, Basic RPM Calculation, Pseudocode. Explanation asterisk. Asterisk. This pseudocode demonstrates a basic method of calculating RPM from the CKP sensor signal. Asterisk. It detects the rising edge of the signal, indicating a tooth passing the sensor. Asterisk. It counts the number of teeth detected over a specific time period, example 1 second. Asterisk. It calculates the RPM based on the number of teeth, the number of teeth on the reluctor wheel, and the time period. Example 2, Ignition Timing Calculation, Simplified C code. Explanation asterisk. Asterisk. The C code snippet illustrates how the CKP sensor is used to calculate ignition timing. Asterisk. It obtains the crankshaft angle from the CKP sensor signal. Asterisk. It calculates the ignition timing based on the crankshaft angle and other factors, RPM, engine load. Asterisk. The ignition advance angle function shows a very simplified advance calculation. In reality, this would be based on a complex lookup table derived from engine mapping. Example 3, Misfire Detection, Pseudocode. Explanation asterisk. Asterisk. The pseudocode shows a simple way to detect misfires. Asterisk. It compares the current RPM to the previous RPM. Asterisk. A sudden drop in RPM, exceeding a predefined threshold, is interpreted as a misfire. Asterisk. A misfire flag is set, which can then trigger a diagnostic code and potentially shut down the affected cylinder to prevent further damage. 6. Important considerations asterisk asterisk. Asterisk. Quality parts asterisk. Use a high-quality replacement CKP sensor from a reputable brand. Cheap aftermarket sensors can be unreliable. Asterisk. Proper installation asterisk. Ensure the sensor is properly installed and aligned. Incorrect installation can lead to inaccurate readings. Asterisk. Wiring diagrams asterisk. Always consult your vehicle's wiring diagrams for correct pin assignments and voltage specifications. Asterisk. Professional help asterisk. If you are not comfortable working on your vehicle's electrical system, it is best to seek professional assistance from a qualified mechanic. Asterisk. Relearn procedures asterisk. Some vehicles require a CKP relearn procedure after the sensor is replaced. This procedure teaches the ECU the new sensor's characteristics. Consult your vehicle's repair manual for details. By understanding the function of the CKP sensor, recognizing the common symptoms of a failure, and following a systematic diagnostic process, you can effectively troubleshoot and resolve CKP sensor-related issues and keep your engine running smoothly. Remember to always consult your vehicle's repair manual for specific instructions and specifications. Good luck.